Flowworks is a very powerful package for helping us verify the function of our design and also for choosing which design is best. You've probably seen the PowerPoint demonstration where we discuss the design problem of cooling inside this power supply enclosure. What we're going to do now is show the results interactively and look at the benefits we get with flow simulation in helping us understand our design. Once the analysis is completed, we can start looking at results. In this case, we're going to look at the 3D arrow display, which shows the direction of the air at different positions through the model. Uh, and the result it gives currently is pressure, but we can easily change that to look at any result type. So in this instance, we're very interested in the temperature in the enclosure. So we can just select temperature from the list. And then we see the temperature displayed on these arrows. So you get an idea of not only the direction the air is flowing, but also the temperature at those positions. Animating that is very beneficial because it then gives you a greater understanding about where the air is going and can identify problem spots. So we can actually see if things like that large capacitor are too much of an obstacle to the airflow and maybe that they need to be repositioned in a different location. There's different ways we can view the airflow. The 3D arrows is one. We also have one which is more of a streamline type display. And this shows the path that a particular particle takes as a line with arrows along it to indicate direction as well. And this is useful for showing us, exactly where a certain stream of air is going through the enclosure. Again, it's another one that identifies areas of recirculation very easily. And also because it shows a path, you can see that some streams actually take a lot longer to go through to the exit where there's recirculation. So looking at these airflows is a very useful tool. But there's other ways we can understand what's going on in the system. For example, we can take a slice in any direction through the interface and look at the temperatures inside. And again, this is one of the powers of doing analysis on the computer, is that it's very difficult to achieve these things in a laboratory test. So we have a great capability in being able to understand exactly what temperature there is at different locations within the enclosure. And you'll see here we see some warm areas at the front, which are due to the recirculation there. Obviously, it's not getting enough airflow to keep it down in that particular location. But not only can we show it statically, we can also, again, adjust that interactively to see what the temperature is at different locations. So we're going to move that up and down just to get an idea, so towards the top of the enclosure, what the temperature distribution is. And then as we move it down, we get a better idea as to what it is around the heat sinks. And you'll see those hotter areas. And again, it gives you a good visualization to showing the airflow in the fluid in those areas as well. One other method we have for showing results is specific to surfaces. So you can actually show the results on the circuit board, for example, which is a very useful tool. And again, you can see you get nice clear representation indicating the temperatures. And here, that capacitor is actually the hottest point. The ICs are just a bit below 100 degrees. So hopefully we've seen a little bit of the capabilities in what we can review inside flow simulation. And obviously we can also incorporate camera positions in these animations as shown here to really help enable you to look inside and understand and convey to other people what's going on in the system. So by providing these in a parametric system, we can again obviously do a lot of changes, evaluate their effects on the performance, and that really does help us choose the best design.